I'm Emma Chenoweth from Chemical Watch, and I'll be moderating the event. Introducing the speakers today will be Dr. Christopher Fassbender, who's the advisor for PETA International Science Consortium. And just before I hand over to him, I'm just going to run through the format of today's webinar. Today we've got two speakers who will each present for about 25 minutes each. We may or may not go to a question and answer session then, but please send your questions in. We'll look at them, and if there are some that can be answered, we'll answer them at the end. Otherwise, we were thinking we might prepare a document of questions and answers. I hope you appreciate this is obviously quite a tricky topic, and we want to make sure the answers are absolutely spot on and correct. So that's how we're going to deal with the questions. But if you can send them in, that would be good, using the questions box on the screen. If you experience any technical problems during the webinar, you can also use the question box to send a query through to Lorna, my colleague here, who should be able to help. Delegates should also know that a recording of this webinar, along with all the slides, will be available on the Chemical Risk Manager website and also on the PETA International Science Consortium website, and that will be available in the next few days. Right, let me now hand over to Christopher, who will provide some information on this webinar series and also introduce you to the speakers. Thank you, Christopher.
Thank you, Emma. I'd like to welcome all the participants to today's webinar on behalf of the PETA International Science Consortium, and to thank Chemical Watch for their support in hosting these webinars. The PETA International Science Consortium is an organization that promotes reliable and relevant regulatory testing approaches that protect human health and the environment while eliminating the use of animals. This series updates the popular 2014 and 2015 webinar series. It includes both live and recorded webinars and reflects the significant progress in the use and acceptance of non-animal methods that has occurred in recent years. Around 1 million animals have already been used for REACH purposes, yet there are provisions within REACH to minimize animal testing. For Annexes 7 and 8 in particular, there are excellent alternative methods that can be used to meet REACH data requirements. It is with this in mind that the Science Consortium has made minimizing animal testing for REACH requirements a high priority. If you check out our website, you will see that we have a page dedicated to promoting alternative methods to meet REACH requirements. Also on our website, we will provide recordings of all webinars in this series. I'd also like to let you know that our scientists are available to assist registrants in avoiding animal testing, so please feel free to get in touch with us if you need advice on how to use the alternative methods discussed during these webinars. Today, we will be presenting the first live webinar in the series, which is focused on alternative methods for skin irritation and corrosion testing. The other live webinars in this series address specific Annex 7 and 8 endpoints, including skin sensitization and serious eye damage and irritation. These webinars will be of interest to industry toxicologists, those registering chemicals, REACH consultants, and companies who would like to know more about validated non-animal tests and how companies are using them. Importantly, I'd like to draw your attention to two recorded webinars that are available on the Science Consortium and Chemical Watch websites. The first recorded webinar gives perspectives on the development, evaluation, and application of in silico approaches for predicting toxicity. This webinar is presented by leading experts in the field, Grace Patlovich from the US EPA and Mark Cronin from Liverpool John Moores University. The second recorded webinar is presented by Kimo Luakari from ECHA and discusses ways to avoid acute oral toxicity testing using weight of evidence approaches. I'll now introduce our speakers so they can present what I know will be a very informative presentation. Our speakers are Drs. Gertrude Emilia Kostin and Costanza Rovida. Dr. Kostin is the Manager of Scientific Services at the Institute for In Vitro Sciences. Dr. Rovida is a chemist working as a scientific officer at the Center for Alternatives to Animal Testing Europe, and a project manager for Team Mastery. During the webinar, Dr. Carsten will describe the in vitro methods that can be used to meet REACH data requirements for skin irritation and corrosion under Annexes 7 and 8. And then Dr. Rieder will use specific examples to explain how the in vitro methods can be used in an integrated approach to testing and assessment. With that, I'll pass the controls over to Emilia to start.
Thank you, Christopher, for the introduction. Hello, everyone. My presentation will focus on the technical aspects of the in vitro methods that are used for regulatory purposes. Next slide, please. These are the main topics that I would like to cover today. We're going to talk about the impact of test substances on human skin. We'll review the animal test used for skin corrosion and irritation assessment. We'll go through the evaluation of these two endpoints using in vitro assays, and we will draw several conclusions related to available testing strategies when we are interested to assess skin corrosion and irritation endpoints. Next slide, please. Let's start with the impact of test substances on human skin. Next slide, please. Besides being the largest organ of the body, skin provides us with a vast physical barrier against mechanical, chemical, and microbial factors, and it has a complex immune network and provides a unique defense system against UV radiation. Skin is very complex in its anatomy, showing a couple of different layers. Of them, the most important one, which is the limiting factor for the penetration of corrosive materials or irritants, is stratum corneum, the exterior layer that sheds off regularly. When a product or a raw ingredient is applied intentionally or it comes in contact with the skin accidentally, can induce different reactions. One is corrosion and the other irritation. On the left side of the slide, you can see a corrosive event, which is an irreversible damage to the skin following the exposure to a test substance. It is usually characterized by ulcers and bleeding, and skin rarely recovers after this event. On the right side of the slide, you can see an irritation event, which is a reversible damage to the skin after exposure to a test substance. It is characterized by erythema, the redness aspect, and edema. These two are critical endpoints that are assessed in the animal study that we will talk about in the next slide. It is important, can you go back one, please? It is important for manufacturers to assess correctly the corrosive and or irritation events on the skin and to add the appropriate label on their product. So assessing these two endpoints is important for registration and labeling of chemicals, for the transport of chemicals, for occupational safety, and also for the assessment of hazard of cosmetics and other household products. Next slide, please. We will talk in the next few slides about the animal test used for skin corrosion and irritation that has been used for a very long time, since the 40s, based on the assay, the method developed by Draes. In brief, the animals used are albino rabbits, and the endpoints, as I explained before, are erythema and edema. As with any other assay controls are used, and you're going to see this for also for the in vitro assays. In this case, untreated skin areas of the test animals are used as a negative control. The assay is used to evaluate the corrosion and irritation potential of test substances, and is covered by OECD guidelines for 404, which was updated last in 2015. Even though this method has been used for a very long time, there are a couple of limitations with it. In general, the rabbit and human skin have different physiological properties, and they respond differently to environmental or chemical substances. Some substances are more toxic to rabbits than to humans, and vice versa. The Draes rabbit test has been also criticized to overpredict, in many cases, the human skin irritation, and it induced debated ethical issues related to the pain induced to the animals, particularly for corrosive materials. Next slide, please. Next slide, please. Thank you. This is a typical protocol for the DRAISE assay. Normally, 1 to 3 rabbits are used in a sequential testing. Many years ago, the assay was using 6 rabbits, but it has been limited more and more. And if events are seen in one animal in a very short time at the beginning of the assay, the study is not continued. Normally, test substances, either solids or liquids, can be tested. They are applied to the skin on the skin surface, and the exposure times are different. Usually shorter for the skin corrosion assay and longer for the skin irritation. There is a reason why the skin corrosion assay is shorter, because corrosives are very toxic and they induce a lot of damage in the structure and functionality of skin in a short time, whereas irritants take a little longer time. It is important to keep these aspects in mind now for the in vitro assays later on in the presentation, because the in vitro assays have been modeled to cover aspects of the in vivo study. After the application of the materials on the skin of the animal is observed for quite a long time, up to 3 days, and then thereafter up to 28 days to observe reversibility. Erythema and edema are calculated for each animal, and a compiled score for both endpoints is calculated, which is eventually related to potential irritation or corrosion potential of the substance in relation to the human event. Next slide, please. Let's cover now how the skin corrosion and irritation endpoints can be assessed using in vitro assays. Next slide, please. As I mentioned, corrosives and irritants interact with skin differently, take different times, they induce more aggressive events for corrosives and less for irritants. To address these two slightly different endpoints, a couple of in vitro assays have been designed and are currently validated. For skin corrosion, I'm going to cover OECD Guideline 430, transcutaneous electrical resistance test, OECD Guideline 431, which is based on reconstructed human epidermis models, and OECD Guideline 435, called Corrositex, or membrane barrier test method. For skin irritation, I will cover OECD Guideline 439, which is based on reconstructed human epidermis models, and it's called the skin irritation test, or SIT. Next, please. Next slide, please. Before we get into the in vitro assays, I would like to introduce the in vitro models, reconstructed in vitro models that are available commercially. They mimic very well the structure of the native human skin, and they are all derived from human keratinocytes. Multiple layers of the skin are modeled in vitro, and these assays, these models are provided in a commercial setting by their manufacturer. They usually, they are reproducible, they showed long-term reproducibility, and they come from the manufacturers with a quality control document. When used in our labs and when used in your labs, you should consider adding positive and negative control to each assays that are performed, and to keep a database of their responses. Next slide, please. The first, we're going to cover the first assay of the for skin corrosion. Next slide, please. And that is the transcutaneous electrical resistance test, OECD Guideline 430. The test system is represented by rat skin discs that were resected from rats, humanely killed rats, generally Wistar-derived or other comparable strains. The assay endpoint is the electrical impedance of the skin expressed as transcutaneous electrical resistance value. The assay uses a negative and a positive control used as water and 10 molar hydrochloric acid. The assay is used to identify non-corrosive and corrosive test substances and mixtures in accordance to the globally harmonized system. One of the limitations of this assay is that it does not allow the subcategorization of corrosive substances and mixtures in accordance to UNGHS. Next slide, please. This is a busy slide outlining the typical protocol for the method. I'm not going to go into detail. I will just point out the main aspects of the assay. All the information on the slide is for you to review later on, should you be interested in the protocol. Usually the discs are placed over the top of a PTFE tube with the epidermal surface in contact with the tube, and the test substances are applied to the epidermal surface of the skin. The exposure time is 24 hours. At the end of the exposure time, the test substance and the controls are removed through rinsing with tap water, and the skin impedance is measured and is used to convert it in tear measurements. Depending on the transcutaneous electrical resistance values that are obtained for the assay, a prediction model has been generated by comparing in vivo and in vitro data. Therefore, depending on the tear values, substances can be labeled as corrosive or non-corrosive, with the caveat being that the corrosive materials may not be subcategorized using this in vitro assay. Next method, please. Next slide, please. The next assay that I would like to discuss is the skin corrosion assay, covered by OECD Guideline 431 and based on reconstructed human epidermis models. There are 4 models, as outlined in my slide: Epiderm, Episkin, Skinetic, RHE, and EpiCS. All these models use the same assay endpoint, which is tissue viability assessed by the reduction of the vital dye MTT. MTT changes colors from yellow to a dark blue or purple when it is exposed to viable tissues. The assay controls are negative controls, usually sterile deionized water or sodium chloride, depending on the tissue model, and the positive control is either anormal KOH or glacial acetic acid, again, depending on the model. Should you be interested to work with either of these models, at the end of the OECD guideline, you should see a comprehensive table that compares the tissue models and outlines specifics of each protocol. The results of the assays can be used for regulatory purposes to distinguish corrosive materials from non-corrosive and to subcategorize the corrosive materials into subcategory 1A and 1B and 1C together. One limitation of this assay is that it cannot separate subcategories 1B and 1C according to UNGHS labeling system. Next slide, please. This is the typical protocol that is used for the assay. For this example, I used images for the Epiderm model from Mata Corporation in US. After the tissues are received in the lab, they are usually stored in the fridge until we are ready to perform the assay. They are then placed into media for at least 1 hour to acclimate them and to account for the difference in temperature. The tissues are treated with the test substances and the assay controls for the time specified in the OECD guideline. For this particular tissue model, for 3 minutes and for 1 hour. Usually we use a 50 microliter dose for the assay. At the end of the exposure, the tissues are rinsed with buffer, and then they are placed in MTT for 3 hours. After the exposure to MTT, the dye is extracting an isopropanol for 2 hours, and the extracted MTT is sampled into a 96 well plate, and the OD optical density is read at a wavelength of 570 nanometer, and it is converted into viability values. Next slide, please. These are the prediction models depending on the tissue model that is used in the assay. As you can see, there are different cutoff values for the exposure times of 3 and 60 minutes for EpiSkin model, and then for Epiderm, SkinEthic, and EpiCS. All these assays are now capable to, all these tissue models are now capable to not only separate corrosive from non-corrosive, but also to subcategorize corrosive materials 1A and 1B and 1C together. In the table on the bottom of my slide, you can see that there are different cutoff values added for step 2 for the Epiderm, SkinEthic, and EpiCS models. This has been done recently in 2015 when the manufacturers of the tissues came together and retrospectively analyzed the data such that the performance for subcategorization of these 3 tissue models reached the level of performance of the EpiSkin model. So now either of these tissue models can be used for subcategorization purposes, keeping though in mind that again 1B and 1C cannot yet be separated. The reason behind this is that not enough materials in these categories have been tested to be able to come up with a prediction model for their proper label. Next slide, please. The last method used for to assess corrosive and non-corrosive materials is an in-chemical method called Corrositex, or membrane barrier test method. The test system is represented by an artificial membrane that is designed to respond to corrosive substances in a manner similar to animal skin in situ. The assay endpoint is represented by the time in minutes required for a test substance to penetrate through the Corrositex barrier membrane and produce a color change in the chemical detection system, CDS. As with any other assay, we use control, negative, citric acid or propionic acid, and positive control, sodium hydroxide, known to not induce any corrosive events or to induce a corrosive event depending on negative and positive. The assay is used to assign UN packing groups to corrosive materials or to verify if a test substance is not corrosive. It is used for transportation purposes. So in the United States, it's used for the Department of Transportation submissions. One of the limitations of this assay could reside with the nature of materials. Usually, materials with a pH between 4.5 and 8.5 do not qualify for testing based on the chemical detection system because they do not induce any color change in the liquid represented by the chemical detection system. The assay works very well for extreme pHs at either end of the spectrum. Next slide, please. This is the typical protocol for the Corrositex assay. Usually, we test each test substance by adding it to the chemical detection system. On the left side, you see the yellowish color. If the color changes into a red color, then it means that the substance can be tested using this protocol. Next, the test substance is categorized to determine the appropriate timetable for the packing group assignment. Usually, depending on the color induced and comparison to the chart provided by the manufacturer, we know that a category 1 test substance will be evaluated for up to 4 hours, whereas a category 2 test substance will be evaluated for up to 1 hour. We prepare the biobarrier membranes according to the manufacturer's instructions, and we place the biobarrier in the cup that is applied to the top of the chemical detection system. And then each test substance is added to 4 replicates of biobarrier membranes, and the vials are continuously monitored for the first 10 minutes. we usually spend a lengthy time, as I said, up to 4 hours, to look for a breakthrough event and to look for the color forming. The time when we see the color changing is the time that we record in the study workbook. Next slide, please. And based on these times and based on the prediction model of the OECD guideline, we can categorize substances into category 1 or category 2, and it's possible to assign packing groups, which are used then by the manufacturers of the test substances to transport these products according to the in vitro results. Next slide, please. In the next section, we will focus on skin irritation and the assay that can be used for regulatory purposes. Next slide, please. The assay is covered by OECD Guideline 439 and uses reconstructed human epidermis models, epiderm, episkin, Skinetics, RHE, and LabSite, all validated for regulatory purposes. In a similar manner with the corrosion assay, the endpoint is tissue viability assessed by the MTT dye. The assay controls are specific to this assay. Negative control could be water or calcium and magnesium-free DPBS, depending on the tissue model. And the positive control is 5% SDS, which is known to induce irritation events in humans. The results of the assays can be used for regulatory purposes to determine the skin irritancy potential of test substances, either as a standalone replacement of the DRACE test or as partial replacement within a tier testing strategy. One of the limitations of the assay is that it does not allow the classification of test substances to the optional category 3 GHS category for mild irritants. Next slide, please. The protocol shares a couple of features with the protocol for corrosion, the RHE corrosion assay that I presented earlier. There are a couple of differences. The irritation protocol is longer because, as I explained at the beginning of my presentation, irritant materials take a longer time to induce visible events. Therefore, the assay covers about four days in the lab. When the tissues are received, they are placed into culture media for an hour. After the 1 hour, the media is changed with fresh media, and the tissues are incubated for overnight to acclimate them before the assay actually starts. We use 3 tissues per test substance and per control, whereas in the corrosion assay we use duplicate tissues. And the exposure time is 1 hour. For the epiderm model, for the other models may vary up to 4 hours. After the exposure time is completed, the tissues are rinsed using a specific rinsing procedure outlined in the OECD guideline, and the tissues are placed into fresh culture media for 24 hours. At the end of the 24 hours, they are placed into fresh media for an additional 18 hours. Therefore, the post-treatment incubation time is 42 hours, and that allows irritants, potential irritants, to induce effects that we can capture in vitro. At the end of the post-incubation, the tissues are again placed in MTT for 3 hours. The MTT is extracted in isopropanol, and the samples are added to a 96-well plate, and the optical density values are read. They are then converted to tissue viability values, and the prediction model has been generated through the validation exercise. If the mean viability of the tissues treated with a test substance is less than 50%, the in vivo prediction would be that the material would be predicted as an irritant. And it would be a category 1 or a category 2 per GHS. Category 1 are corrosive, so we would need eventually to perform the corrosion assay to separate category 1 from category 2. I will discuss more about this in a few slides. If the mean viability of the tissue is more than 50%, then the in vivo prediction is non-irritant, and then the test substance would be a no category, basically a non-irritant. Next slide, please. I would like to draw a few conclusions after my presentation. Next slide, please. The assays that we have discussed thus far are designed for regulatory purposes, and they rely often on a single exposure time, on a single dose, or on a single cutoff value. They usually are designed to provide a yes or no type of answer to the question, is a product a corrosive or an irritant? They are frequently ingredient oriented. The validation assays have been performed using pure chemicals, whereas the chemical domain of manufacturers is concentrated more on formulation. In the interest of sound science, animal welfare, and recent regulatory requirements, in vivo testing should not be undertaken until all available data relevant to the potential dermal irritation and corrosion of test substances have been evaluated in a weight of evidence analysis, and all the other possible approaches have been exhausted. There are multiple possibilities to draw a conclusion before any testing takes place, residing with human studies, evidence of corrosion or irritation based on structure of the substance, pH, and so on and so forth. Next slide, please. I would like to outline the tier testing strategies that are available depending on the chemistry domain. For example, concentrating on the left side of my slide, the top-down strategy would start from the assumption that a product could be corrosive based on previous data, based on structure, pH, and other physical chemical characteristics. We can perform the in vitro corrosion assay, and if the test substance is predicted to be a corrosive, it can be labeled like that. If it is a not corrosive material, we cannot draw a conclusion about its irritancy potential. And then, in this situation, the bottom-up strategy outlined on the right side of my slide can be used. In that strategy, we would assume that the substance is not corrosive, possibly an irritant, and the in vitro skin irritation test would be performed. If the test substance would be predicted to be a non-irritant, it can be labeled as such. If it is an irritant, and if we started the strategy from the bottom-up approach, it will be necessary to confirm whether the product is corrosive or not. As you can see, this testing strategy is self-correcting in many respects, and it's often used in industry. This completes my talk, and I'm happy to hand it over to Dr. Rovida. Thank you.
Okay, good afternoon, everyone, and thank you for the nice introduction. Next slide, please. Before I start, I would like to show you some numbers just to give you an idea of what we are talking about. This is the snapshot of the ECHEM portal, which permits the query among published data, including worldwide regulatory programs, like the public database of registered substances that is available in the ECHA database, in the ECHA website. The query is based either on a specific substance or by endpoint. By clicking chemical property data search, followed by skin irritation, and either in vivo or in vitro, it is possible to have an idea of how many new tests are performed per year. Next one, please. These are the results that combine in vitro and in vivo methods to test skin irritation. The two peaks of the graph are clearly related to the two reached deadlines. The first at the end of 2010 and the second one mid-2013. As you see, the number of in vitro tests is higher than in vivo, but it also demonstrates that the in vivo is very much used. Unfortunately, there are still no data related to the latest reach deadline of 2018. I hope to see there a much higher number of in vitro tests. But why am talking about that? Next slide, please. REACH regulation was first published in 2006. REACH is based on the principle of no data, no market, indicating that any chemical needs to have a full toxicological profile to be placed on the market. The extensiveness of the registration dossier is proportional to the average quantity that is either manufactured or imported into the EU by each single company. Registrants are requested to use the EUCLID software distributed for free from the European Commission. In the main screen of the EUCLID software for the preparation of a file for the dossier, there is a drop-down list to select the type of submission, as you see in the top left. Mandatory endpoints for the specific tonnage band are marked with a little red star. Please note here that skin irritation and corrosion is requested for all main registration above 1 ton per year. Next, please. To fulfill any endpoint information, there are always plenty of possibilities. REACH keeps a preferred track for alternative methods, as declared from the very first statement in Article 1, where the promotion of alternative methods is clearly declared. Article 13 is dedicated to give priority to alternative methods as soon as available. This is repeated in Annex 6 to describe how to prepare the dossier, and also, even not, though not shown here, the title page of Annexes 7 through 10 contains the same sentence. Next slide, please. Very important, Annex 11 of REACH describes how to adapt standard testing approach. Please note that this was a real revolution, and REACH was the very first regulation in the world accepting data from innovative methods. Now there are many other examples, and the concept of testing strategy is accepted, at least in theory, in many other regulations. However, this paragraph of Annex 11 generated confusion in the past, as it asked for confirmation in vivo to accept a negative result from an in vitro method. However, the text is clear, and the demand is restricted to non-validated in vitro methods only. But what does it mean? Next slide, please. Let's review the story of the validation of in vitro methods for the assessment of skin irritation for chemicals. OECD published the methods for skin corrosion in the years 2004 and 2006. Skin irritation was added in 2010, and in fact in 2014 there was availability of the new guidance on testing strategy for skin corrosion and irritation. Therefore, full implementation of REACH Article 1 and 13 plus application of Annexes 6 and 7 through 10 would have led to the complete abandoning of the in vivo method. As confirmed by the numbers retrieved from the ECHEM portal, this did not fully happen. Next slide, please. But now it is different, and since May 2016, the text of Annex 7 about skin corrosion and irritation has changed. Next, please. Also in Annex 8, the request for in vivo study is explicitly limited to very specific cases. Compared to the past, the situation is completely reversed, and the in vitro test is the main and only mandatory need. Next slide, please. As a consequence, also the EUCLID screen for skin irritation was updated, even though I would have preferred a much more intensive revision. To select the endpoint, the drop-down menu offers the selection among in vitro and in vivo. Next slide. The EUCLID form asks to indicate the applied method for the specific experiment. The form contains the list of officially accepted methods, including the in vivo test. The content and the order of this list is very interesting. First of all, you can see that OECD references are listed before the EU methods of the Regulation 440/2008 to underline the fact that any new OECD publication can be immediately suitable for REACH purposes. Please remember this and always try to stay updated on new methods. Next slide, please. The strange aspect of EUCLID is that the selection on strain is still there, even though a OECD in vitro method was selected, And it's even more aberrant that the list includes the monkey, whose use for the general assessment of chemical toxicity is forbidden. Next slide. But let's go back to more practical issues and consider the case when there is an existing in vivo test for skin irritation that was performed much before the validation of the in vitro alternative. In this case, the use of that test is not only possible, but strongly recommended. Be careful, because if you just insert the in vivo result alone, you may face a validation error of the dossier. In fact, reach ask for in vitro method first and face the control if there is none, as you can see here. The submission of such a dossier will cause an immediate rejection. I personally think that this is very important, because eventually it's the demolition of this general cliché in many traditional toxicologists that regulators accept in vivo methods only. Next slide. To solve the problem, it's very easy. You have to insert a new record containing the waiving reason for the in vitro test. Suitable justification is necessary, as proposed in the example here. Next slide, please. But in the end, what do we need? First of all, we have to assign a hazard class to our substance. According to the CLP regulation, regarding skin irritation, there are three possibilities: non-irritant, irritant, category 1 or 2. That corresponds to the label H315 or H314 with the correlated pictograms, but that's not enough, of course. Next, please. The other class 314 triggers the application of special provisions for transport as detailed in the ADR book. The class 8 for corrosive substances includes three packing groups corresponding to the CLP subcategories 1A, B, and C. I don't go into further details now because it is a complex topic and out of the scope of my talk, even though very important if you are handling a skin corrosive substance. Moreover, I always consider skin irritation together with eye irritation due to the obvious relationship between these endpoints, including the fact that the other class H314 is in common. Even though there are few exceptions, eyes are more sensitive than skin, and therefore it hardly ever or even never happens that skin irritation has a more severe category than eye irritation. This must be taken into account when setting a testing strategy. Next slide, please. The registration of a substance placed on the market in quantity above 10 tons per year must undergo to the chemical safety assessment, leading to the chemical safety report. That is included in the registration dossier. The CSR must contain also the exposure scenario that describes the safe use of a chemical. In case of skin and eye irritation, the definition of a threshold of concern is not possible, and the assessment is qualitative. The decision about whether we are dealing with low, medium, high concern depends on many factors that are well described in the chapter R8 of the ECHA guidance on information requirements and chemical safety assessment. Practical guidance 15 is very useful for the definition of the risk management measure to be used in the exposure scenario for endpoints that have no risk in a threshold. Next slide, please. So, Emilia has very well described all the available in vitro methods for the assessment of skin irritation potential. I've just talked about what the REACH and CLP requests are, but how do we get there? Next slide, please. In this sense, ECHA is providing an excellent support, and the guidance R7A contains a dedicated section on skin corrosion and irritation, where there is a detailed description about how to handle available data and how to build a successful strategy. In particular, Figure 2 lists all the steps that are necessary in the assessment. Next slide, please. Figure 2 is very long, and I don't go into the details of each single step. Jumping to line 1C and D, we read that the first advice is on physicochemical properties. For example, the pH alone can be enough to stop the process and immediately assign the category 1. Be careful that little notes in this figure are important and don't underestimate them. For example, note A in this example says that the pH is a possibility and not an obligation, and the new test may avoid such a severe classification. In general, I strongly recommend to consider physicochemical properties before any other toxicological study. They are always mandatory for REACH, and they are very helpful to get to know your substance and its general behavior in the human organism and also in the environment. Simple information such as the impurity profile or the water solubility is fundamental for a proper selection of the study protocol. Next slide, please. Step 2, ask for existing human data. This is very important, but also untrustworthy. Data on humans are available in particular for occupational exposure as well as consumer use. Unfortunately, there are also reports coming from accidents that can add information. Reliability of this data is generally low because derived often from multiple exposure, and the extrapolation of the effect of a single chemical is difficult. However, many chemicals that are now considered by REACH have been manufactured and used for years, and usually workers know very well if a substance is irritant or even worse, corrosive. Even if this information can be used as a key study, it still provides the idea of the substance property. Next slide, please. After the availability of human data, the strategy asks for existing animal data. This step seems easy, but it's not. Reliability of animal data can be very difficult, in particular if they're old, they were performed with no GLP compliance and unclear identity of the tested substance. For example, I found all these data in the table in the skin irritation record of one registered substance, as published in the ECA database. As you see, there are 6 studies with discordant results. Cleanish score is assigned by the registrant, and it is not always meaningful. I am not the author of this dossier, but it seems that the corrosion result is the consequence of a very long exposure, as it happens only after 24 hours of exposure, and this may derive from a possible degradation of the test material. There are other confounding factors in vivo studies. Skin sensitization should not be ignored, as it may interfere in the resulting from an existing in vivo test, or even colored substances may trigger false positive estimation from an operator. It is a matter of fact that reproducibility of in vivo studies is poor. In 2015, we analyzed the ECA database, and we found 7 or 9 chemicals tested more than twice with the in vivo test, and we could calculate a sensitivity of 68% and a specificity of 83% of the DRICE test. And both numbers are quite far from 100%. Next slide, please. Line 5 of figure B joins together QSR approach and read across. The two concepts are not really equivalent, as described in the dedicated webinar of this series. To apply the read-across approach, please refer to the so-called ECA RAF document, the read-across assessment framework, that explains how to present the data in the dossier in order to get to a full acceptance. Regarding the QSR approach, I just mentioned the QSR toolbox that is downloadable for free in the link that is present also in the homepage of the ECA website. Be careful, because this toolbox has great potential, but the application is absolutely not trivial and recommended only to expert users. The application of a QSR model is absolutely not straightforward, and this gives me the opportunity to say that risk assessment is hardly ever performed by just one person. Rather, a team of experts in the different sectors are always fundamental to get to a reliable conclusion. Next slide, please. Regarding QSR, there are also many commercial products, like this one that is marketed by UL. The advantage of this system could be that there is the automatic preparation of the iUclid record to facilitate the compilation of the dossier with all the required information that is fundamental for the full acceptance of the QSR result into iUclid. Next slide, please. Last step before performing a new test is the scouting for existing in vitro method. Don't forget that the weight of evidence approach offers the opportunity to join together many data. None of it sufficient to fulfill the information requirement. Note that non-validated methods can be suitable if there is some conclusive evidence. This is very important, and it is an explicit invitation to stay updated on the evolution of in vitro testing. We are today talking of skin irritation, but the principle is valid for any other endpoint. For this reason, I take the opportunity to invite you to participate in the next ESTIV Congress that will be in Berlin in October. ESTIV is the European Society of Toxicology in Vitro. Next slide, please. We are now in the point when a new test is necessary. This is the well-known flowchart for top-down and bottom-up approach. This particular figure comes from the ECA guideline, but it is also present in the OECD 203 and many other papers about the validation of the in vitro methods, as already explained by Emilia. According to this schema, 2 tests per substance is often necessary for the definition of the skin irritation or corrosion hazard. This is true if the skin irritation endpoint is considered detached from any other information we may have. Next slide, please. I say again that gathering existing information should be considered globally. I have already talked about physicochemical properties. I insist here on the importance of considering them all together in a global assessment to understand the general behavior of a substance. For example, also molecular weight and octanol water partitioning may provide a clue for interaction with the skin layer. It's also clear that reactive substances like oxidizer may have a stronger impact on the skin. In this phase, special attention is given also to the possible involvement of the respiratory tract. Data on dermal toxicity are very relevant, but also skin sensitization should not be ignored. QSR modeling is very helpful, even if not enough to get to a conclusion, as it may offer an important support in the decision of whether applying the top-down or bottom-up approach. In conclusion, we needed to collect enough data to limit the uncertainty for our substance on 2 categories only, like corrosive or irritant to go to the top-down approach, or irritant and not irritant to apply the bottom-up approach. Next slide, please. The top-down approach is applied when there is a suspect of a severe activity of the substance. Actually, very often, the corrosivity hazard is well known, and the test is performed just to assign the correct packing group for transport, as explained by Emilia. If the test result is non-corrosive, there is generally so much evidence to conclude that the substance is irritant in a weight of evidence approach, and the second test to exclude the classification is generally useless. Next slide, please. The bottom-up approach is more challenging. This procedure usually starts from the OECD 239. If the result is negative, the process is stopped, concluding that the substance is not irritant. This test should be performed before starting the similar approach for the determination of the eye irritation endpoint, because when the substance is not irritant for the skin, the bottom-up approach for the eye is applied. If the result for the OECD 439 is positive, we cannot immediately assign either category 1 or 2. And we must be very careful in the definition of the weight of evidence approach without further testing. The positive result here immediately triggers the application of the top-down approach for eye irritation. Vice versa, in case the eye irritation test is already available, it can be used to support the weight of evidence approach here. Next slide, please. The conclusion is general and not restricted to skin irritation. So the advice is to start from the regulatory framework and do what is requested and what is possible. There is no unique instruction, and even single-tier strategy should be tailored to the specific substance and the specific use. Assessment of the substance should be performed globally, not endpoint by endpoint. This goes together with the advice of getting to a conclusion when all data are available, and not just at the end of the single experiment. Last but not least, the optimization of a strategy includes cost and simplicity. The breast approach is completely useless if in the end is not applicable in practice. Thank you for your attention, and I am now ready to reply to your questions.
Thank you very much, Costanza. So, yeah, we have had a few questions in, and I've forwarded them to Emilia and some to you as well, Costanza. Now you've finished your presentation, maybe you could have a look at them. What I was going to do is maybe ask, there's kind of 3 or 4 each per presenter. So if I start with Emilia, and I think, Costanza, if you want to add anything to Emilia's answers, I think we're all unmuted, so we can have a bit of discussion. So the first question I've got here for Emilia is there a fundamental technical reason why the potential for both corrosion and irritation can't be predicted in just one in vitro test method, facilitating a one-step testing strategy? Is such a method in the development pipeline?
I can answer that. Thank you for the question. I think one of the main reasons is the capacity of irritants and corrosives to induce any changes in the tissue models that we explained. The corrosive materials actually take a very short time to destroy the tissues. Sometimes 3 minutes are enough. So if a material is a corrosive in 3 minutes, it's nothing else that we can assess. So it will be labeled like that. You don't even need to cover irritation. You have your answer right there. Irritants take a longer time. So it is impossible to assess anything in the same time frame. In 3 minutes, they will not probably induce much events in the tissue model. So we need to consider, based on the validated method, a longer exposure to start with, 1 hour or 4 hours, then allow a post-exposure such that the materials that penetrated the skin are now in the under layers can induce some toxicity events that we can capture in vitro. So I think it's a matter of the nature of products, their capacity to induce either irritation or corrosion, and their penetration rate. So chemistry is key to this question, I think. It would be nice, I agree with you, to cover both, irritation and corrosion in the same single protocol. And I guess out of convenience, at least to use the same, dosing volumes, which is not the case for the validated methods. But I would say, I'm not saying from knowledge, I would assume this type of assay is not probably in the pipeline, since we have validated assays already in place. It was a lot of work that went into validating already 2 very stable methods to come up with another one, I would think. Okay, then. And someone else here has asked about whether or not there are online databases of skin irritation testing results that contain both animal and human data. I would say there are lots of data, but they're scattered here and there. It will take, time to put them all together, but there are a couple of resources. There are data in the background review document for each method, for corrosion and for irritation. Those are animal data. Human data, there are a couple of manuscripts that are available that I could share with the person who asked the question. I also published a book chapter a year or two ago where I tried to find and correlate animal data with clinical data. So it's not like a single database that maybe the person asking had in mind, but there are resources. So I would be happy to share.
Maybe if you could, yes, if we could collect them together, we could make a little package of information. I'm sure a lot of people would be interested in that kind of information. Okay, another question for you, Emilia. In the case of a mixture with an extreme pH, has a low buffer and is tested negative in OECD 430 or 431, could it be classified as skin irritant, so that's H315, or not classified based on the CLP additivity approach? Sorry. For instance, if H315 substances are less than 10%, it would not be classified. So did you follow that question?
Yeah. That is a complex question. I guess based on the strategy that both of us explained, the logical way would be to continue with an in vitro assay rather than the calculation. Maybe Costanza could have some input here, because I cannot say really that I know what companies do in this situation. If it were for me, because I work in a contract lab and we're more inclined, to do testing, in vitro testing, I would say since 430, the OECD guideline, let's assume, was conducted, or the corrosion assay was conducted, I would say let's continue logically with a skin irritation test using the same tissue model and see where the data takes us instead of calculating. But again, I don't know what companies do for registrations in that fashion when they're facing this situation.
Costanza, would you like to comment on that?
It's I mean, it's a case by case. It depends on the results, whether it's clear or not, on the substance. And so in my experience, I hardly ever perform two tests for the definition of skin irritation, because there is always much evidence from other sources to understand what is it. Different is for corrosive substance when you have to define the packing group. So in that case, you may need extra tests for that.
And actually, I've got another question here, Costanza, that I sent on to you, which you may have just answered, but there may be more to add to it. Sorry. So this is saying OECD 435 is not accepted for CLP classification irritant.
Unfortunately, this is not the only cases, because the CLP is not really in line with REACH and with the new in vitro methods. I know that there is a discussion at GHS level on this topic, and skin irritation actually is not the main problem in this sense. I'm sure that during the webinar of skin sensitization, this topic will be tackled as well. Anyway, as far as regards Europe, the European Union, what is the classification defined for REACH purpose is fully accepted also for CLP. But I have no idea about what's happening outside the EU, also because in many other countries some in vitro methods are not accepted, so the problem is much broader.
So is that the kind of the challenge? Is that the stumbling block, the acceptance of these tests, or is that? I mean, the second part of that question is what can science do to promote this? Is it a question of science, or is it a question of time and just the regulatory acceptance process, getting more and more evidence?
Regulatory acceptance process, of course. So we are now trying to change in few years what was done for many years. So I can understand that's not easy, but I'm quite sure that this is the right way to go.
Yeah, and I don't know if you've seen this question, but it relates to occupational exposure data and whether or not that could be considered. Basically, the person that's asked the question says very little quantitative skin exposure data that's published.
But very little, I would say none. I mean, skin irritation is usually not a threshold hazard. So, in fact, when you do risk assessment, you have to define whether you consider it a low, medium, or high hazard. So, of course, if it's corrosive, it's very high. And if it's irritant, you have to decide based also on many other aspects of the problem. So, but that's very well described in the ECHA guidance. So I really advise to go there. That's R8 for exposure and number 15 for practical issues.
Yeah. Okay then. Right, maybe one last question for you, Costanza. It involves bath bombs, so I feel as though I have to ask it. I don't know if it's actually it might be quite a technical answer, so if it is, just say. But the question is, how would you test a dry mixture of corrosive substances which, when wetted, become lower or no hazard? For example, bath bombs with citric acid and sodium carbonate.
I love this question because it's a typical example of what I have just said. So before testing, you have to understand which is your substance. And so if you put citric acid and sodium carbonate into water, in the end, you have sodium citrate. So your chemical substance has changed. And therefore, you test the final product. And this is also, not really this is the reason, but I just remind you that, for example, for CLP purposes, when you have a mixture, you can define the classification of the mixture through the presence of single ingredients, or test the mixture and decide whether the specific hazard is confirmed or not. And for skin irritation, this happens very often, that the mixture has a lower classification than the single ingredients. But in this specific case, it's a completely different chemical substance.
Okay then. I can see, I've been looking down at all the questions I had written down here from the delegates during the webinar, and I can see since I've been asking them, there's another kind of dozen or so being asked. But I think what we'll do is we'll collect those together and come back to you with some answers to those in a kind of follow-up document. I think it's time to wrap up the webinar now. So thanks for the questions, thanks for responding as well. And I'd like to thank Emilia and Costanza for their presentations there. It was very interesting, very informative actually. Quite a few of the comments we've had coming in through the webinar is thanking them for the information, so it seems to have gone down well. We have had well over 600 delegates signed up to this event. I think over half of those have listened in, and I'm sure the others will download the event in the next few days. It will be you'll be sent a link with the slides and the recording as well, so you'll have that. There's also, as you can see on their screens, more webinars in this series. There's the recordings that Christopher mentioned at the start of the webinar, but we've got 3 more updated webinars coming up through February as well, so watch out for those. And I'd also like to point delegates to the new test methods database that we have on Chemical Risk Manager. If you were listening in before the webinar when we couldn't mute ourselves, I spent a little time just telling the people that were there, that we've got this new website, Chemical Risk Manager, which is trying to really focus in on this area of hazard identification and test methods. So there's a load of resources there that you might find useful. Without further ado, I'd like to thank you all for listening in. Thank PETA as well for their support and participation in this. And one final thank you to Emilia and Costanza. Thank you very much.
Thank you.
Thank you.